productONE and OneWorks empower innovative African companies with our software, services, training and support solutions to improve their profits, reduce their risks and grow their businesses. Our customers are often small businesses, usually owner-managed, but also include listed and international companies. It's companies that develop and manufacture products or systems. These range across the fields of retail, consumer, mining, industrial equipment, and aerospace and defense. We help our customers who want to expand with new products into new markets, who want to cut costs, both in product development and in the products themselves, as well as improve their efficiency in their operations and return of assets.
Our solutions are changing the world of design development. We can help you design faster and smarter and improve your design quality.
PTC has really gotten this right. They've understood, I think, the methodology, what they call the thing object, the means of creating that digital twin of a physical thing out there in the world. We're all humans and we all need to relate to something in the physical world. So the thing model that they've created is a really powerful means of doing that. And it makes it therefore easy and quickly to create these systems and to scale them across an enterprise. And I think that has taken a huge amount of bespoke coding and development out of the equation.
It's awesome working for a company that's forward thinking and provides exciting career paths for young African minds intent to making their mark in the world of tomorrow.
So with our PDC certified implementers, we have grown alongside PDC. We started in the early 90s with their revolutionary CAD system, which is now Creo. We moved on and expanded with their Winchell PLM system, which was the first internet-based system in the world. Today, we're dealing with their service lifecycle management and application lifecycle management solutions. Together with our subsidiary OneWorks, we are recognized today as leaders in the fields of industrial Internet of Things, augmented reality, and 3D printing as well. PTC has allowed us to do all of these things. So we ask you to partner with us on our massive transformative purpose of making African products great.
Good morning, everyone. My name is Tashi. I'm the COO of productONE Solutions. Thank you for joining us this morning. As you can see from this very basic agenda, the bulk of our time will be spent in the main session with Wasani and on the Q&A to answer your all-important questions. Before we begin, we will be recording the session. We will upload the recording to our YouTube channel and we will share the links after the session. Please post your questions in the chat section of the webinar to be addressed at the end in the Q&A. Just before the Q&A, you will be prompted to participate in a poll. We ask you to please participate for those few seconds. Product design can determine up to 80% of the final cost of a product, with concept design determining up to 60% of that cost. Over-design or even under-design can lead to bad brand reputation, bad customer experience, and it will either drive sales down or it will drive costs up. Companies aspire to grow. Whether you want to grow from increasing your revenue on new products or increasing your profitability on existing lines of products, the leadership of a company will come up with a high-level strategy that the organization should embark on to meet the company objectives. From that strategy, various initiatives are passed down to functional heads, or these functional heads are asked to come up with initiatives to meet the company objectives. Once we understand the initiatives that we'll be embarking on as a company, we really need to understand the set of activities that ultimately lead into the company's processes that will lend itself to meeting the company objectives overall. Once we understand these processes and activities, we need to then understand what capabilities in the organization that the company needs to employ, either through technology or its skills and its people. Whilst productONE is certainly in a position to speak to you about strategy, initiatives, and optimizing various processes, today's webinar is laser focused on the capability portion derived from technology. Concept design is an important part of the design process. It's very important in this part of the design phase that you are able to quickly and efficiently interrogate a number of design approaches and to see the impact of those approaches so that you can make certain decisions and have choices. FEA analysis and further analysis is an expensive exercise. It's also a pretty scarce skill. So what you ultimately want to achieve is getting to the point where you are feeding only final designs for confirmation of the integrity of the design approach, rather than testing a whole bunch of concepts with that expensive resource. So without further ado, I would like to pass on to Wasani, who will then embark on unpacking one of the technologies that PTC has brought to the market for concept design phase. That's Creo Simulation Live. Wasani is a principal application engineer with productONE. He specializes in Creo with a subject matter expertise in simulation and top-down design methodology. Wasani has over 8 years experience in product design, having served some time in the rail and defense sectors before joining productONE. Over to you, Wasani.
Thank you, Teshi. So, sure. I really like that introduction, but then I hope it doesn't give me a big head. So today, as Teshi mentioned, we are going to be looking at PTC's products, which is Creo Simulation Live. Let's get into it. Okay. So as Teshi mentioned, companies are seeking to grow. And what they've realized is that when it comes to design, they will need to achieve one of the following goals or all of them in order to grow. So they need to better understand how their products perform. They need to reduce development cycles and also improve time to market. They also need to reduce their design cycle time and then be able to create fewer prototypes, increase product quality and performance, thus reducing warranty and repair costs. So PTC saw this and embarked on a journey to assist PTC's customers in order to achieve all of these goals. So before we get into the solution that PTC found, let us look at where these things can be achieved, which is the design process. So the typical design process starts off with a concept or multiple concepts, and then one concept is chosen, which is moved on to the detailed design. And then from the detailed design, in order to validate the design itself, a prototype has to be created. If any errors are found from the prototype, it either means that it has to go back to the drawing board, which is the concept phase, or if it's an error that can be fixed in the detailed design, it can be fixed there. And once that error is fixed, it goes back to the prototype. So what happens here is you cannot go to manufacturing until you have a working prototype. And sometimes you might have to create multiple prototypes in order for you to get one working prototype that can be manufactured and put out to the market as a product. So what PTC has seen is that the use of simulation is very important in reducing the number of prototypes that are created. So I know that some of you have worked or have seen high fidelity simulation products such as Creo Simulate and Creo Ansys Simulation and Creo Flow Analysis. But high fidelity tools such as these ones, or as we call them, traditional analysis tools, are usually used at the end of the design process, once the detailed design has been created. And the reason for this is because people see it as too time consuming to use in the early stages of the design process, because the design itself from concept to detailed design keeps on changing. So what this leads to is designers and engineers relying solely on their experience, and the decision itself lies or is backed by intelligent guesses and sometimes manual calculations. So since the simulation itself is done at the end of the design process or at a later stage within the design process, if any errors are found, it basically would require rework, and in other cases it means a whole lot of rework. You might have to go back to the concept and then recreate a new concept, which increases the design cycle itself. So what this ends up doing is it creates two separate worlds, one for the designer who is creating the models, and then the other world for the analyst who is running the simulation. So what PTC is looking to do is to break down the wall between these two worlds, and then for their customers to work in a unified modeling and simulation world. So how are they achieving this? So PTC is achieving this by introducing in Creo capabilities such as autonomous design, which is in generative design, and also instantaneous simulation, which can be seen in Creo Simulation Live. So these two tools are introduced in the earlier stages to the mid stages of the design process to help mitigate for that simulation that is required in the early stages. Okay, so in today's series, we're going to be looking at Creo Simulation Live. So what is Creo Simulation Live? So Creo Simulation Live is the integration of ANSYS Discovery Simulation Engine into Creo to provide real-time analysis for simulation. So what does that mean for the designer? So this basically means that you can rapidly define and perform simulations on parts and assemblies because you are working in the same Creo interface, and there is no need to export parts or create mesh. You can run your first simulation within minutes. Yeah. So it allows you to make changes to the design while the simulation itself is running. As you are making these changes to the design, you can see the result of the simulation dynamically update. And it is powered by ANSYS, who have been a leader in simulation for the past half a century. So let us look at the capability. So you can perform a static structural, a thermal, a vibration, and fluid simulation inside of Creo Simulation Live. Okay, so let me get into the demonstration to show you how Creo Simulation Live works. So for the demonstration today, I will be a chassis designer who works for a company that designs and manufactures trailers. So I've been tasked by my manager to reduce the mass on the chassis so that we can increase the payload on one of our best-selling Antipa trailers, which is this one here. So since I am a designer, I have been given a bit of guidance by the analyst on what the maximum stress or the maximum von Mises should be. And for this particular demonstration, I will start with this orange beam here, which is the main beam. Okay, so before I go into the demonstration, so that you can see the demonstration clearly and be able to see everything that I'm doing during the demonstration, I would like you to set your screens to full screen mode by just selecting the top 3 buttons on the top of your Microsoft Teams meeting that you're in at the moment, and then selecting full screen and unchecking gallery at the top. Okay, just give you a few seconds to go through that. Okay. All right, let us look at the part that I'm going to be working on. This is the main beam of the chassis. So as specified, the analyst gave me a target von Mises to work to. So I have to be in between, in between 100 megapascals and 110 megapascals to ensure that the integrity of this beam and to ensure that it can still function and its warranty as well. Okay, so those who have used Creo already know this interface. So what has been added is just an additional tab to the interface, which is called Live Simulation. So as soon as I jump into Live Simulation, if you have any loads or constraints, it does show them. So I've been advised by the analyst on the loads and constraints that I'm to use, and then I've added them to the model. Okay. In Creo Simulation, you can run a structure simulation study, you can run a thermal, you can run a modal, you can also run a fluid simulation study. So all of those things you can run within Creo. Okay. So, but for this demo, what I'm going to be looking at is the structure or structural simulation. Okay. So you will see as soon as I start the simulation, it'll start running. But before we get to that, I just want to show you that in Creo Simulation Live, you have an option of getting results quickly, but then they are less accurate, or getting more accurate results, but at a slower rate compared to it being on the faster side, on the speed side. Okay, so for this simulation, I'll just leave it closer to the speed, but then a bit more accurate. Okay, all right, so to start Creo Simulation Live is as easy as one click, and then what is happening is in the background, Creo is running Creo Simulation Live, and then you are able to see the results instantaneously. You can also see that it also shows me in colors where most of my stress is and where the least of my stress is. So I can look at the legend, and the lighter blue tells me that that's where the least stress is. And then if you look at the red there, that's where the most stress is. But what I'd like to take note of is these here. Okay, so I have a target stress that I have to work to, and I have the current stress that I am running in the simulation that's currently showing me. So you can see on the legend there, it's the same as this one. But what's important, and the instruction that I've been given, is to reduce the mass. So we can see what the original mass currently is, and we can see what the current mass is, and we can also see what the mass difference is in kilograms and also in percentage, so that we know if we are on the right track or not. Okay, so looking at the part that I'm working on at the moment, I can, from the stress, tell that we have over-designed it. Okay, so this happens a lot when people are just guessing and not really informed using such tools. So what I'm going to do is make a change and see what effect the change has on the von Mises stress and also on the current mass. So the first change that I'd like to make is to make the web of the beam a bit thinner. So let's just take it down to 10 mils. The original was 12. So let's see what happens. You'll see that Creo Simulation Live is running, and then it's giving me those results instantaneously. So I'm able to see that, yes, I have made this beam. By making the change, the beam is now weighs less, 54 kilograms less now. And I can also see that the von Mises stress has gone up a bit. But then I'm still not close to the target von Mises or the von Mises that I have been told not to go above. So that means that I can even go further and make another change to the thickness of the web and see what that change does. Okay. So I can see that with that change that I just did, the mass now is way higher. The mass that I'm saving is way higher now. It's 107 kilograms. It means that this particular beam is 107 kilograms lighter, which means that goes into the payload itself. But then I'd like to make more changes to this beam. But then when I look at it here, the von Mises stress is around 103 megapascals, and I'm afraid that the changes that I might make might compromise the strength of the beam. So what I'd like to do first, before I continue with the changes that I want to make, is to strengthen the beam a bit. So what I will do first is just have a look at my beam. Okay. And then have a look at where the most stress is acting. So the blue portion tells me that that is the least stress, which is the low one. And then the red is telling me that that is where my most stress is currently is. So what I'd like to do is reduce the stress there by making this support channel a bit wider. Okay, and then if I was making such changes without a tool like Creo Simulation Live or high fidelity tools, I wouldn't be able to see what effect that change has. Okay, so by just making that change, you can see that that maximum stress has moved from that side there to that side over there. That tells me that that change that I made has made a difference. It has made this particular part stronger. Okay, so what I'd also like to do is continue further strengthening this beam before I make any further mass reductions. So what I'd like to do now is to add another support onto this part by creating geometry there. But then what I also have to take into consideration is that as I add, yes, I might be strengthening the beam, but then what I'm doing is that I'm going back now. My mass difference is becoming lower because I'm adding more weight onto the part. Okay. And then as I can see here, the stress has reduced slightly. The difference that I made, the support that I have here didn't make that much of a difference. Okay, so this I can see because I am informed. And then what I could do is go on to where that stress is acting, which is at that portion there. But then I can see that it's not on the side that I created the support, but it's on the other side, which is here. So I can create another support on that side. Okay, and then see what the stress difference is if I create that support there. So as you can see, my mass difference is much lower than what I had when I didn't have all of these supports here. But then what I'm happy with is I'm still, I've lowered my von Mises stress, which means I've strengthened my part. And then now I can make the changes that I need to make with confidence. Okay. Since you're doing all of this inside of Creo Parametric, you are able to leverage on tools such as design exploration. Okay, so what design exploration will allow me to do is to create multiple concepts that I could share or review with either my manager, the analyst, or anyone else who's involved in this particular design. So I'm happy with the strength that with the strength of the beam at the moment. So now I want to reduce the mass. Okay, so what I can do is create cutouts, for instance, on this beam, such as those ones. And then what I'd like you to take note of is what the mass difference is there, and also what the maximum von Mises is when I'm creating such concepts. So if I were to do this without any guidance, it would be a bit difficult for me to get here without having an analyst run a simulation and then bring it back to me and tell me whether I'm still within the targeted von Mises or I'm above that. If I am above, then I'd have to go back and make changes, which does increase the design cycle. Okay, so now you'll be able to see that my von Mises is still under what is required there, and my mass has significantly increased, which I'm happy with. So I'll save this as a concept. So this I will save as concept that I will share with everyone who's involved in this design. Yeah, so I can create another concept from this. So what I want to do is just to go back and, for instance, change the shape of the cutouts that I'm creating. Instead of having squares now, let's see instead of having circles, let's see what happens if I have squares. What happens to my maximum von Mises, and also what will happen to my mass there. So I can clearly see that my maximum von Mises shot up from under 100 megapascals to around 109 megapascals. So I can see it shot up by just changing the shape. But what's good is that my mass difference has increased. But then, is this enough? I won't know until I run further tests on it. But then let's add this as another checkpoint. Okay, so this has been created as another concept or a checkpoint that I could go back to my manager and show him that I've managed to reduce this much weight by just creating cutouts such as this ones, and also reducing the thickness of the web. Okay, so since I saw that this one here has lower stress, but then does give me a mass difference that's close to the squares, what I could do, I could go back to it and then, for instance, maybe increase what the diameter of the circles are. Okay. So once I do that, you'll be able to see, or I can save this as a checkpoint as well. So let's just call this bigger diameter checkpoint. So I know that this is the checkpoint with the bigger diameter. But then what you will see here or what we need to take note of when it comes to this one saves more mass compared to the other two design concepts I have. And what I'm happy with is that the strength is still kept, because this, the von Mises stress that I'm getting from this particular concept is much lower than the two previous concepts I had. So it basically means I saved more mass, but then I still kept the strength. So having a look at what Creo Simulation Live has given me is information that I need to be able to create proper designs. Okay. Let us just go back to the slides and recap on what we have looked at now. Okay. So what we have achieved today is that I was able to reduce the mass as per mandate from my manager, and I was also able to keep the strength. I'm sorry that you can't see it at the moment, but then that is 93 megapascals, and then the mass difference here is 134, which means that I was able to save 134 kilograms. Okay, so what that basically means is that not only did the mass decrease, we were also able to decrease the cost of material by using a thinner plate for the web of the beam. So we went from a 12 millimeter plate to an 8 millimeter plate. Okay. And then we were also able to increase the payload by 268 kilograms, because the beam on the left-hand side, the main beam on the left-hand side, is the same as the one on the right-hand side. So from 134 on the one beam multiplied by 2, we get that 268. So this value could also increase if we look at other parts on the chassis, or if the designer who's working on the bucket design also goes through a similar exercise. Okay, so what Creo Simulation Live gives us is the ability to develop high quality and high performing products that are easily differentiated in the market. For instance, with those cutouts that we have there, our customers or people out there would know that that was designed by our company. Okay, so we did all of this whilst we managed to maintain the integrity of the main beam, which means that we are able to avoid costly recalls and repair costs. Okay. Since Creo Simulation Live allows us to perform simulations earlier in the design, as you saw in the conceptual phase, and we can perform those simulations often, this allows us to reduce the design cycle time. This also reduces the time to market, as we are able to resolve design flaws earlier in the design instead of much later in the design cycle. So, for instance, if I were to come up with a concept that exceeded the required von Mises or the specified von Mises by the analyst, then I would be able to pick that up earlier on, rather than having to wait for the analyst to go run a high fidelity simulation and then send back the information to me to go and update the design. So this, just going back into when I was studying out in design, I know a lot might relate with this. When you're fresh and new, you have a lot of concepts that you want to try out. But the problem is, if those concepts are not informed, it becomes a bit difficult to see them through to becoming a product. And when I got a bit more experience in design, I was sort of afraid to try out new things because of what I already knew. But then with a tool such as Creo Simulation Live, I can try out new concepts and see whether they do meet the product requirements or not. If they do, then we can go on to the next stage of the design cycle. Okay, so that is me for today.